All right, guys. Hello. This is our first online video for Honors Chemistry. We're going to start with Chapter 11, and this will be kind of the format we'll be using, at least for the next couple of weeks. The process will be that you will have a video to watch, and you will watch that before we come to class, and then when we meet on Tuesday, we will use our Zoom time for working through problems, questions and answers, and just connecting back up. Okay, so this is chapter 11, and we're going to go over just the first little bit of the chapter. So let's go ahead and jump in. This chapter has to do with acids and bases, and we're going to start by looking at some properties of acids. We know that acids taste sour. Not that you should be tasting them, but if you were to taste an acid, it would have a sour taste to it. Acids are also covalent electrolytes. We're going to jump back to that in a minute. But just kind of tuck that away. Acids are covalent electrolytes. And finally, acids turn blue litmus paper red. Now I want to talk for just a minute about what litmus paper is. Litmus paper is a type of indicator. What is an indicator? Okay, well, an indicator is a chemical that undergoes a distinct observable change, and it's usually a color change when the conditions in the solution change. Okay, so some indicators will be one color in one type of solution, in an acidic solution, and they will be a different color in a basic or an alkaline solution. We're talking about a different kind of indicator, and that is that litmus paper really indicates by a color change whether a substance is acidic or basic. For an acid, if you put blue litmus paper in an acid, it will turn red. Now you need to understand that if you put blue litmus paper in a base, it will do nothing. It will stay blue. But blue litmus paper exposed to an acidic solution will turn red. Okay, so those are three properties of acids. Now let's jump down here just a minute and talk about this covalent electrolytes idea. If you remember all the way back to chapter 4, electrolytes are chemicals that conduct electricity when dissolved in water. In chapter 4, we were looking at ionic electrolytes, and we were looking at substances that had metals in them, and when those metals were placed in a solution, what happened was that the ionic compound broke into its constituent ions, its constituent charged particles, and that meant there were particles with charges present in the water which allowed the electricity to be conducted. If you remember all the way back to chapter 4, we also learned that covalent compounds dissolve differently. They dissolve one molecule at a time. And because they dissolve one molecule at a time, there are not charges present as it dissolves. And therefore, we learned that covalent compounds do not conduct electricity. So let's go back up here a minute, and we're talking about the reality that acids are covalent electrolytes. So we're going to learn more about that in just a minute, but I want you to understand we're talking about the fact that a covalent compound has some ability to conduct electricity when dissolved in water. We're going to learn in just a minute why that is, but just kind of tuck that idea away for now. All right, let's jump down now and look at some properties of bases. Okay, so bases. We have three properties for bases. Bases taste bitter. They are also, oops, I got a typo. They are also slippery or slippery to touch when dissolved in water. That's another property of a base. And finally, bases turn red litmus paper blue. And here is my little way to remember that. Bases turn the paper blue. So if you put a piece of red litmus paper in an acid, it will do nothing. It will stay red. But if you take a piece of red litmus paper and expose it to a basic solution, or also called an alkaline solution, that paper will turn blue. Okay, now let's jump down for just a minute and talk about the difference between an acid and a base. Okay, so an acid is defined as a chemical or a molecule that donates H+ ions. A base is defined as a chemical or a molecule that accepts H+ ions. Okay, now in order to understand that a little better, I want to talk just for a minute about the hydrogen atom. If you remember, hydrogen is what? What number is it on the periodic table? Okay, hopefully you said it. It is number 1 on the periodic table. That means that it has 1 proton and 1 electron. Now, if we're talking about something that is an ion, and okay, we're talking about H plus ions here, that means that particle has become charged. And we know that particles become charged by either gaining or losing electrons. If it were a situation where hydrogen would gain extra electrons, then it would have an overall negative charge. But that's actually not what's happening. What happens with hydrogen is that it loses its 1 electron, leaving it with an overall charge that is positive. So once it loses that 1 electron, it now has an overall charge, because there is 1 proton, oops, I lost my P, of H plus, okay? That is now an H plus ion. Now, one of the things I want you to understand about hydrogen ions is that hydrogen only has 1 proton and 1 electron. So if hydrogen loses its 1 electron, what is left? What is left is that hydrogen now has only 1 proton. That is what is defined as. So you will oftentimes see acids defined as proton donors. Okay, we see up here that it donates H plus ions, and what that means is it donates 1 proton. Okay, a base is often defined as a proton acceptor. And again, what it's accepting is an H plus ion, which is simply a proton. Okay, so if you see an acid called a proton donor, that simply means it has the ability to give hydrogen atoms that are charged particles that have lost an electron. Okay, now let's jump down and talk about what that all relates to in terms of acids being covalent electrolytes. So when an acid is placed in a water solution, it donates these H plus ions, meaning there are now charged particles present in the water. So those charged particles then allow electricity to be conducted. So that is how an acid is a covalent electrolyte. It's because it has the ability to donate H plus ions or protons. All right. Much of the chapter is going to be spent learning how to identify when you've got a chemical reaction, which substance in the chemical reaction is an acid and which one is a base. And that'll be the next part of the lecture that we'll talk about. I do want to leave with one other idea, and that is that some substances can act as either an acid or a base. We call that an amphiprotic. We call it amphoteric. Amphiprotic is the same kind of idea, but a substance that can that can act either as an acid or as a base is what we call an amphoteric substance. And I've written here, I'm going to write over it a little more darkly, the most common substance that can do that is water. Now, one of the things that's really important that you understand is that these amphoteric substances can act as an acid in one chemical reaction and as a base in a different chemical reaction. It cannot act as both an acid and a base in the same chemical reaction. But it turns out that with some chemical reactions, the conditions are such that it has the ability to act as an acid, and in differing situations, it has the ability to act as a base. So that's what we've got for now. Our next lecture time will be focused on looking at particular acid-base chemical reactions, also identifying which substances are the acids and which ones are the bases. So that's what we've got coming up. But that's all you need for today. I hope this was helpful, and I look forward to seeing your faces bright and early on, well, not as bright as normal, not as early as normal, but at 8:30 on Tuesday morning. All right, guys, see you then.